another from Brazil. This look kind of.
I think you'll find this one a little bit easier than the other one, probably. I don't know.
Even easier? No.
I think it's even easier.
All right, let's see. ABCD is cyclic. Maybe I should move around. R and S are the reflections of AB with respect to the bisectors of CAD and CBD. I'm just thinking how to best set this up. Okay, so right, so let's draw the two angle bisectors, and then they meet on the circle, obviously, and we can reflect them through those two angle bisectors. And then we see, yeah, it probably would have been easier. You know what? I'm going to do it like this just because it's bothering me. I'm going to draw the whole line AB instead of just a segment AB, or I'll just draw both of them. This almost looks like a trapezoid, but okay. So where is it? Where's my reflect? Reflect AB about both the bisectors. Whoops. And let it intersect at a point P, and O is the center.
Michael, don't you think it would be nicer for GeoGebra? GeoGebra, I don't know how to say it in English properly, but to put a function that what? You put the circumcenter, like.
Yeah, so GeoGebra has a way of doing, if the circle already exists, you can just type in to do the center of the circle. I3435 actually taught me that, although I should have learned it a long time ago. But I think I'd seen Evan Chen do it on his channel, but I was just never bothered doing it. But yeah, there's like, I feel like GeoGebra should have an altitude function. I don't know why they don't. I feel like there's a few things that would make it easier. So yeah, we take AB and we reflect it over. Yeah, let me just draw the whole line. You know what? Let me draw the ray actually. So I'm going to hide the lines, but I'm going to draw the rays just because I feel like it might be helpful. So basically, this ray is like the reflection of AB over this angle bisector, and this ray is the reflection of AB over this angle bisector, and they meet at P. We want to show OP is perpendicular to CD. Okay. Let's see. So that's the same as showing that PC equals PD, basically. Yeah. If PC equals PD, then we know OP is perpendicular to CD. Are there any congruent triangles? I don't see any obviously congruent triangles. So let's see. So another way of saying it is we want to show P, O, and E are collinear. Maybe that's true by like Desargues or something. If we can show P, O, and E are collinear, that would do it. Maybe that's true by some kind of radical axis idea. Let's see. I feel like it might help. Extend CD. So let's see. So BA and BF. So basically, these are both kites. Like FEAB is a kite. Or wait. No, I don't think it's necessarily a kite. Okay, so ABC is a triangle with circumcenter O. And E is like the midpoint of arc AC. Yeah, let me move around the diagram a little bit. So AB and AF are reflections, and AB and AG are reflections. So those are both 62.9. Like we also have angle BAC is equal to angle BAG, right? So basically, yeah, so BH is parallel to CD. Yeah, BH is parallel to CD and AI is also parallel to CD. These are all parallel. So yeah, I think that solves the problem. Yeah. I solved it a different way, but I think Arabian Math also had a solution. Let me see. I'm going to write out my solution, and then I'm going to go read Arabian Maths. But let me see. I don't think you need all these. I'm going to hide some extra stuff that I drew in. Definitely don't need. Let's see. Delete that. Delete that. Yeah. What did I do here? Basically. Like. So yeah, let BP meet the circle at I and let AP meet the circle at H. So I'm going to type it out. We'll say let lines I and H respectively. Okay. And then angle I, we can show angle IBA. How did I do this? So how did I show their parallel? I forgot what I just did. So if we take AB and we reflect it over BE, let me draw some rays in. So I'm just going to pick, just for reference, I'm going to pick, going to call this G and J. So my claim, I forgot what I did. I had it in my head, but I forgot. But so the angle bisectors of CBD and CAD concur at the midpoint E of arc CD. I'm just going to write in that step. How did I show IA was parallel to BH? I had an idea, but I forgot what it was. Well, okay, so first I want to show angle BAC is equal to angle HAC, and that's true by an angle chase. So angle BAC is equal to angle BAE minus angle CAE, which is equal to angle, yeah, this is it, JAE minus angle DAE, equal to angle HAC. So if angle BAC is equal to angle, this should be HAD, then they intercept equal arcs. So that means arc BC is equal to arc HD. And so that means BH is parallel to CD. Whoops. And then similarly, AI is parallel to CD. And so BH is parallel to AI. And so if that's true, then by symmetry, if BI and AH meet at P, then PO has to be perpendicular to all three of these. It's the whole figure symmetric. So I don't even know how to say this exactly, but if BH is parallel to AI, BH AI is an isosceles trapezoid. And so P lies on the perpendicular bisectors of everything. like AI, BH, and CD. So OP has to be perpendicular to CD. Whoops. Here we go. Let me do it like this. All right, does that make sense?
Yeah, it makes sense.
All right. Let's move on to the next one. Okay. Let me see how much. Oh, I got to plug in my computer. Hold on one sec. All right. So we have the 2011 Swiss team selection test. This one I think was kind of tricky. Oh, actually, no, this one does not look as tricky. So we have the triangle ABC. D is the perpendicular from A to BC. Yeah, I wish there was like an altitude button in GeoGebra, but there isn't. E and F are the midpoints of AD and BC. Whoops. Didn't mean to do that. E and F. G is the projection of B onto AF. And we want to show that EF is tangent. Oh, sorry, Arabian Math. I forgot to look at your way of doing the last problem. Actually, I'll just continue with this, and then when it's over, I'll look at your way of solving the previous problem. Okay, so we want to draw like the circumcircle of GFC, and we want to see if EF, we want to prove that EF is tangent to that. So we want to show angle EFG is equal to angle FCG. All right. Let's see. It looks like an easy problem, but who knows? Maybe it's harder than it looks. So let's see if that were true. Like, I wonder if we could find a triangle similar to AFD. Basically, let's try this. So F, yeah, I'm thinking. Trying different things in my head. I feel like there's got to be some right triangle that's like similar to AFD. Yeah, what if we draw the perpendicular from C to AF? I think that might help us. Yeah. Because then actually, I'm not sure. Yeah. So we want to show angle AFE is equal to angle AGC. Is it true that angle E? So, yeah, but I don't think G is the midpoint of AH. So No, so I don't think that that strategy would really work. Let's see. Whoops. No, yeah, those angles aren't equal. 43.6. Let's see if there's like another trick. Yeah, how do we get AFD to be like similar to, so if we can't, if that doesn't work, dropping the perpendicular from C to AF, is there some other kind of perpendicular? I mean, is it the same as, I think we have to show C, G, and E are collinear. Is that true? No, not necessarily. But like, what if we extend CG to meet AD at a point? No, that doesn't. And then, like, what if we draw perpendicular to AC? That might be useful. So, like, let's see. I'm trying to get this to like, I want to see where AD intersects. This line is, I want this line to be less vertical. It's too vertical. This is so hard to, I'm going to see what Arabian math suggestion was. Oh, you can't, sorry, you can't open your mic. But yeah, you can always just post in the chat. You know what? I don't think that was a good strategy to draw these. Can I draw the center of that circle? Yes. Call it O. Connect it with F. Yes. So we want to show angle EFO is 90. So yeah, what if I like drew that? Yeah, we have to use that AD is the altitude. So HF is parallel to AD. Maybe that would help. We want to show EFO is 90. We know DFH is 90. So we want to show EFD is equal to HFO, which is FH. Yeah, we also, I haven't used that G as the projection of F, of B on the AF. Yeah, there has to be a trick here. No, I was, or actually maybe, I was thinking different points before. No, E, G, and O are not necessarily collinear. And, yeah, you just have to move the diagram around a little. Okay, so we want to show EFG is equal to OFH, which is equal to OHF, which is 90 minus angle OFC. Which is like 90 plus OF. Yeah, I feel like there's got to be some. Can you draw? Yeah, I can draw. Yeah. There has to be some similar triangles here. So if we take the midpoint of HF, I mean it's like we want to show OIF is similar to EDF. Maybe they're even congruent. I doubt it. Yeah, they're not congruent, but oh wait. Yeah. So I is the midpoint of HF, E is the midpoint of AD. These are concurrent. I don't know if that does much. I feel like maybe I'm making this harder than it has to be, but let's see. So maybe like a homothency, so angle, we want to show angle EFA. So by homothency, EFA is equal to ICH. And we want to show ICH. So we want to show these are, we want to show CA as a symmedian, basically. Or no, we want to show CG as a symmedian. I feel like I might have like an overkill solution. Let's see who's on. Arabian. EF is the mid segment. It connects the two midpoints. So yeah, EF is parallel to AC. I think that probably might solve this. So EF. Well, no, because F is the midpoint of BC. So F is the midpoint of BC, not the midpoint of, yeah. But I think I might have like an overkill solution. Let me see. That's all right. We want to show EF is tangent. So yeah, angle EFA is equal to angle ICH, which we want to show is equal to angle GCF. So yeah, we want to show triangle IHC is similar to triangle GFC. Wait, is there a way to show triangle AEF is similar to triangle GFC? I feel like it's probably just ratios or something. Project from F. AD CGFH. Hold on. ADE infinity project through F onto the circle is CGFH, so it's harmonic, and that solves. Okay, that seems like an overkill solution, but so we have found the solution. It's kind of an overkill solution, but maybe there's a faster way. Yeah. I don't think I assumed EF was tangent in the proof. But hold on. So basically, we want to show triangle GFC is similar to triangle AFE. That seems like it should be doable, right? I feel like we're just missing something. So hold on just a sec. Where's my measure? Is that actually true? GFC is similar to EAF? No, I was missing something somewhere. Wait. But why is it not true? Wait. Hold on a second. Is so AD is parallel to HF. What? What's going on here? AD has to be parallel to HF. Something's weird here. Okay. So this, oh, but this angle is not equal to that angle. Projected geometry is really useful. So it looks scary, but I just watched 2 of my videos on it. It's like maybe like 10 minutes for each video, and just that already teaches you like enough to solve 90-ish% of the problems that use projective geometry. So yeah, I would recommend that, but it's just no Desargues theorem. Yeah. Let's see. Okay, so let's see how we can do this. Yeah, we want to show angle GCF is equal to angle ICH. So we want to show that's a harmonic quadrilateral. If you call P the intersection of AD and BG, then BG-PF is cyclic. That's true. Yeah, and in fact, P is the orthocenter of ABF. So yeah, but let's see it. Like, yeah, basically. Yeah, we want to show angle EFD is equal to angle CHF, which is equal to angle CGF. Let's see. If we reflect G over F, okay, so I'm gonna delete a bunch of stuff. GDP is similar to GCF. Okay, I think we have two. Hold on just a sec. I'm seeing a whole bunch of different things here. I'm gonna first look at John's solution and then Arabian Math. So GDP is similar to GCF. Okay, so I'm gonna look at Arabian Math's idea. So I'm gonna delete a bunch of stuff in the figure. That's probably unnecessary. So Arabian Math is saying, what we do need that, just reflect G over F. To point G prime. Then CGT, what is T? Is T a point I had before? T is a reflection of G. Oh, that's T. Okay. Okay, so this might be it. Let's see. So CGT is similar to ADF. How do we show that? Or we want to show that. But that might just be an angle chase, I think, because it's a parallelogram. Yeah. So okay, so it's really much simpler. Yeah, we were making it much harder than it had to be, but the solution is really simple. Yeah. All right, so I'm going to write this up. Okay. And so then BGC is, oh, sorry, like this. Okay. And if that's true, then since angle BGF is 90 degrees, angle TCTG is 90. So okay. And then we also have, hold on a sec. So ADFE, I think you mean GCTF, right? Yeah, okay. So we have one more pair of equal angles, because, wait, we still need one more pair of equal angles, right? Okay, actually now I'm wondering a little bit here. So is it obvious? So yeah, so we have an equal pair of angles. So angle FAD is equal to, I'll write it like this. CT. Okay. So that means that FAD, well, but we already knew that. Yeah, I think it might not be that obvious that those triangles are similar. Like, you want to show GCT is similar to AFD. Is that obvious? I thought it was obvious for a second, but I don't. Maybe not. Yeah, maybe it's not so obvious. I don't see why GCT is similar to AFD. I see they're both right. I see they're both right triangles. But why are they similar? Okay, now I think I might. Well, if we can show angle TFC, is angle AFD equal to angle FED? Now I'm getting really confused. That doesn't seem like it should always be true. EDF and CTG. Yeah, they're similar. How do we show they're similar? I think we can show they're similar. Let's take the midpoint of DF. So then EH is parallel to AF, right? And so angle E, yeah, I mean, yeah, we can prove that they're similar. I see a way to do it. So let H be the midpoint of DF. ED over DF equals CT over TG. But how do we know DF over AF is CT? Yeah, that's basically what I was trying to do by constructing this point H. Wait, DF over DA is equal to CT. Okay. I'm gonna write it out this way. So I think what I'm saying is essentially the same. So let H be the midpoint of DF. So then HE is parallel to AF. And so that means angle DHE is equal to, that means triangle DHE is similar to triangle TFC, right? So and then DH is equal to HF, and FT, EF is equal to FG, means that CGT is similar to what is it? DEF. And then from there, and H corresponds to F in those two triangles. So that means angle, yeah, what was I doing here? That means angle C, yeah, what am I doing? Is that true? CGT is similar to EDF? I thought it was. Wait a sec. No, oh no. Hold on. Wait. DHE is DFA is CFT. So DHE is similar to CFT. 32.4, 32.4. So yeah, H corresponds to F. That's right. And what was my plan? Yeah, so then we'll do it like this. And if that's true, angle GCF is equal to angle HEF is equal to angle AFE. And so EF is tangent to the circle. Wow, this is so much harder than it had to be, I feel like. Oh well. All right, next problem. Still have like 40 minutes left. So feel free to stay as long as you like. Yeah. Wasn't that a fun one? All right. Let's move on to other problems. This one looked fun. I looked at this really quick, but I didn't really solve it at all, but it looked interesting. So ABC is an acute triangle. No, I'm sorry, obtuse. K is the circle with diameter AB and center O. Let's call this O. Let's draw a circle. Circle of ABC. So I'm going to draw that in. Okay, I'm not going to draw the center yet. Why not? Call I the center. It touches AC and AB at M and N. I wish there was a faster way to change names other than doing this. MN intersects the circle at X and Y. And we want to show angle XOY is equal to angle ACB. Okay. It seems simple, but by Iran lemma, AIY is collinear. Okay, because you're saying if MN meets A, I think I have a YouTube video on this where I show like YC is parallel. No, YC isn't necessarily parallel to AB, but I'm trying to think why that's the case. So basically, if we hide the circle, you're saying the intersection of AI and MN is at a point perpendicular to AY. Let's see. So that's Iran lemma.
Oh, Iron Lima is I've seen like the book that the guy that was here before wrote, and it's like a lemma that was on a test from Iran and says some collinearity of points. Like I don't know exactly what is it, but I think Arabian math can say it more properly.
Yeah, so basically, yeah, AI and Y are collinear by that lemma, and BY and X are collinear. I feel like I'm trying to remember the proof. I think it might just be like poles and polars or something. Because basically, Y lies on the polar of C, so C lies on the polar of Y. Maybe something like that. Angle chasing. So we have CI is perpendicular to MN, and we want to show YI is perpendicular to YB. So that kind of means we want to show, it's probably just angle chasing. Yeah, AIMX is cyclic. Yeah, so yeah, we can show AMIX is cyclic, and BYIN is cyclic. So yeah, I see how that follows. So let's just assume for now that these are collinear. I'm going to write out the proof in the chat later.
But does this solve the problem?
I'm not sure. So not that I see right now. I think it, let's see. Yes, the rest is just an angle chase. Okay, so angle XOY. Yeah, because angle XYO, because angle XBA, I'm just trying to think about this. Yeah, because angle XOY is 180 minus AOX minus YOB, and AOX is half of XBA, and YOB is half of YAB, and so that should just be an angle chase. All right, so I'm going to write it out. The final problem is kind of tricky, so we'll finish on a tricky one and we'll see if we can solve it. All right, let me think about how to best write this up.
And Arabian math, why, I'm seeing Arabian math solution, but why is 2xAy equals ACB? You put in the chat.
So he's saying angle XOY is 2x. Oh, he thought of it a little differently than I did. But angle XOY is going to be 2 angle XAY because they both intercept arc XY, right? And so that's the first part of, that's the first equality, right? And then 2xAy is equal to ACB. So it's lemma 1.45 in EGMO. Okay.
Oh, I know this lemma.
Yeah. I'm going to prove everything from scratch here because I don't think it's super hard to do it. So when we started the problem, we didn't know that these were collinear or these were collinear, right? But it's not hard to show that I think it's not hard to show that AIMX is cyclic. But Y is 2. So yeah, I'm not 100% sure why, but I had a different way of thinking about it. My way of thinking about it was, so angle XOY, it's 180 minus XOA minus YOB. And XOA is half of XBA, and YOB is half of YAB. That was kind of my way of thinking about it. So 2XAY is 2IMN. Oh, once you know that those are cyclic. But yeah, you really don't even need to know that those are cyclic. You just need to know that these points are collinear. So yeah, so if I delete those two, how do I show AI and Y are collinear? So trying to think. So it's probably just an angle chase, but so basically CI is perpendicular to MN, so CI is actually, hold on a second. Yeah, I'm just trying to remember the proof in EGMO that AI and Y are collinear. Let's see. Suppose CI meets MN at a point X prime. Okay. I can draw that in. Oh, okay. So this is X prime. And then we want to show basically AX prime MI is cyclic. AX MI, okay, yeah, that is cyclic, yeah. But we have to hide the circle. Okay, so so then by an angle chase, basically AMX prime is equal to AIX prime. Okay, so I'm gonna write this out. So then I'll move on to the last problem. The last one I doubt we'll finish in time, but it'll be interesting just to get started on it. So yeah. So write it like that. Then by an angle chase, we can show AI mx prime is cyclic. So write that out. Okay. So AIMX prime is cyclic. And then that means angle AX prime, so I'll write it like this. Right. And then similarly, y prime equals y. All right. So now we can draw in that circle. And we can get rid of the primes. I'll just leave it as x prime and y prime just so we know. And then now it's an angle chase because we have YB. Okay. And that no, this should be two, not half, 2. And that's just 180 minus angle A minus angle B is equal to angle AC. And that solves it. All right, so I'll move on to the very last one, which is pretty tricky. We can see how far we go for let's see. So this one, did I have another problem? No, that was my last one. This is number 18 on the Sharygin. So we have a triangle ABC. AM is the median. So M is the midpoint of BC. Omega is the end circle. Ah, you saw it. Okay. All right, so I guess I'll see how far I can get, and maybe you can give me and John some hints. So omega is the incircle. It touches it at point T. And AT meets the circle at S. Amaro 4 had a solution. All right. And let's see. We draw the tangent. Let's see. Where's the tangent? Hold on 1 second. AM, BC, and that tangent. So I'm going to draw that point in E. So we draw the incircle of triangle DEM. And we want to show its tangent to the circumcircle of ABC. That looks kind of hard, but let's see where we can get with it.
You didn't put point C, you put point F there.
Oh, whoops. Good call.
It sounds pretty difficult. This one.
So there's these things called like curvilinear in circles. So there's like mixilinear in circles. So like this circle right here is the yeah, it's called like a curvilinear in circle because it's tangent to the circle and AM and BM. But M is not like point C. All right, let's see. So basically, like there's a homophoby at D taking one circle to the other circle. Let me try something. So if I drew that tangent, then it would be a mixilinear in the circle. I don't know if you've heard of like Sawayama's lemma. Yeah, let me check something for 1 second. So you use Sawayama's lemma? Then I should probably use it. So yeah, so I'm going to draw the centers of these two circles. So whoops, hold on just a sec. I want the center of that, center of E. No, I want the center of the in circle, I'm sorry. Center of C. And then if I draw the angle bisector and I let it meet FG, so I'm going to hide some things. Sawayama's lemma says that I think there should be another circle like this that's tangent. And these circles are like all sort of homothetic. Let's see. Huh. Something interesting is going on. But yeah, F, G, and H are collinear basically. The other Thebault circle of AM. Is that other, this is the other Thebault circle, right? All right. I'm glad I at least got to that point. So yeah. The thing is, we don't know that this one is actually the Thebault circle. We do know that, trying to think. So F lies on the angle bisector of AMB. H lies on the angle bisector of AMC. Yes. So yeah, I'm trying to think of a way of like rephrasing this problem. And we can show the tangent at S is the common tangent to all three circles. Yeah. So it's like, so we're showing the tangent at the end circle to point S is also tangent to the two Thebault circles, with AM as the Chebyshev. It's another way to say it. Now why? I would think, let's see. Yeah, so these points all lie on the angle bisector of D. So S is the reflection of T over FH. So I don't think, yeah, our BCT, I think this, does KL pass through D? Yes. So D, B, C, and T are in harmonic conjugation. Basically, we need to show the common tangent of those two Thebault circles, and cuts BC at a point that's in harmonic conjugation. If we let IA be the AX center, then IAM is perpendicular to FH. That's interesting. Well, is FH perpendicular to AT? I guess it's easy to show that GD is perpendicular to AT, right? So GD is perpendicular to AT, and so FH has to be perpendicular to AT, and so yeah. you're saying to draw the AX center. Let's see. And then IAM is perpendicular to FH. I think I could show that. Let me do that. So this is going to be a crowded diagram, but I will attempt to do that. So let's draw on the X circle. Let me draw some rays. Let me try to make it look better. So we have the X center here. Actually, I don't need point N. Or wait, what did I just do? So we could call this IA. And then IAM is parallel to AT. That's from the in-center X-center lemma, I think, because I don't, yeah, I think that shouldn't be hard to prove that. So IAM is parallel to AT. And so it's perpendicular to FH. Let's see. All right. Does that solve the problem? Maybe I'm missing something. Or there's more steps. So yeah, I haven't even drawn the X circle. Might be a good idea to do that.
Michael, I'm sorry, but I guess I'll have to go.
Oh, that's fine. I was just about to finish up anyways. I think I'll stop it right here. But thank you both for participating. And yeah, this was a lot of fun.
Thank you so much.
So yeah, I'll
for
see you
having
again.
us.
All right. Have a good rest of your day.
You too. See you next week, guys. Bye-bye.
Bye. See you guys.